Okay, so today we're going to be talking about the cloud architecture. Okay. Now, the topics of this class are going to be AWS well-architected framework, right? Reliability and high availability, AWS trusted advisor, AWS well-architected framework, design principles, interpret AWS trusted advisor recommendations. Like we have seen, we have said in the past, whenever you see trusted advisor, right, then you will see this word, which is a keyword to identify trusted advisor. It's the word recommendations. Okay. Whenever you see a service that offers recommendations, that's going to be trusted advisor, right? And some people know it um, as the cloud expert. Okay. So after this module, you will be able to describe the AWS well-architected framework, including the 5 pillars, right? Don't forget that, 5 pillars. Identify the design principles of the AWS well-architected framework. Explain the importance of reliability and high availability. Identify how AWS Trusted Advisor helps customers. And interpret AWS Trusted Advisor recommendations. So the first section is AWS well-architected framework. So here we have a graphic that shows the structure, design, and the completed structure. So guys, architecture is an art. And it's also the science of designing and building large structures. So large systems require architects to manage their size and complexity, right? So for example, cloud architects, the people working behind the scenes in this architecture in the cloud, they engage with decision makers to identify the business goals and the capabilities that need improvement. They ensure the alignment between technologies, deliverables of a solution, and the business goals. They work with delivery teams that are implementing the solution to ensure that the technology features are appropriate. So having the well-architected system greatly increases the likelihood of a business success. Okay, it's like when you're building a house. If you plan it out well, you're going to have a strong, a firm, solid house, right? They're going to withstand any storm, any strong winds, things like that. Same thing here, right? So here we have the design of the house, right? And then here we have the complete product, which is the house already built, right? So what is the AWS well-architected framework? It's a guide. It's a guide that is designed to help you build the most secure, high-performing, resilient, efficient infrastructure possible for your cloud applications and workloads. So it provides a set of foundational questions and best practices that can help you evaluate and implement your cloud architectures. So AWS developed the well-architected framework after reviewing thousands of customer architectures on AWS. Okay? They're always improving and improving the well-architected framework. Okay, so it's a consistent approach to evaluating and implementing cloud architectures. It's a way to provide the best practices that were developed through other people. So architectures that customers design. Right? The pillars of AWS well-architected framework: operational excellence, security, reliability, performance efficiency, and cost optimization. Like I said before, every time you work with the cloud and you try to convince a business owner to migrate to the cloud, they always ask you the same question: how much am I going to save here? Because cost is important, right? My business has to operate excellently, okay? With excellence. It has to be secure, reliable. It has to have performance efficiency, and it has to be cost efficient. So those are the pillars that AWS always tries to implement in every single architecture. Okay. So don't forget this 5 guys, right? Let me ask you in the exam. Let me say which of the following are pillars of the web architecture framework, or which of the following is a pillar of the web architecture framework. Let me ask you to answer one or two answers. Okay. The bad thing about the questions in an AWS exam is that if they ask you to answer more than one choice option, it is everything or nothing. If you made a mistake, if you choose one correctly and the other one incorrectly, you lose everything. It's not like Azure. When you do Azure exams, if you have 3 answers and you just answer 2 right and 1 wrong, you get 2 points. With AWS, it's everything or nothing. So be careful, read carefully, take your time. 1 hour and a half is more than enough to answer 65 questions for a basic exam. Right? Pillar organization, best area. Okay, best practice area, identity and access management. Okay, remember that IAM is going to be there all the time. Okay, IAM is one of the pillars of all the services in AWS. So the question is, how do you manage credentials and authentications? Okay, so the context of this question is that credential and authentication mechanisms include passwords, tokens, and keys that grant access directly or indirectly in your workload. Protect credentials with appropriate mechanisms to help reduce the risk of accidental or malicious use. IAM, you can create groups, you can create users with IAM, you can create secret keys, access keys with AWS IAM, and you can save them where? Do you guys remember where you save the credentials? What is the best place to save the credentials? Do you guys remember? I mentioned it a few classes ago, and also I demonstrated.
KMS?
Which one?
KMS?
No, KMS is to deal with keys. That's different. I'm talking about storing the keys, not the keys, the credentials. So what's the best place for that?
That'll be the
Vault.
No, a vault is for Glacier.
Secret.
Yes, you're warm. Secrets.
I can't remember the other word.
Secrets.
Storage.
No.
Manager.
Manager. Secrets manager. That's the best place to save credentials. Okay. And what is the other one? The second choice. The second best choice.
Identity and access management?
Nope. Parameter store in Systems Manager. Remember parameter store that you enter the key and the value, and then you can encrypt it. Remember, the first place is Secrets Manager. The second best place is the parameter store that is in the Systems Manager, which is another service. Okay, parameter store. Okay. Okay, so the best practice is define requirements for identity and access management, secure AWS account root user. What is the best practice? What do we do with the root user? What do we do with the keys of the root user? What do we do?
MFA.
No. What do we
root key?
The access key and the secret key of the root user. What do we do with it?
Delete the keys
We
and disable the account.
Or disable the keys of the root account. We disable or delete the keys. And what keys do we use? Because we have to access the account, right? So what do we have to do to still have access to the account?
Create an
Create an IAM user. Create an IAM user and What privileges?
Enable
What
multi-factor.
What privileges do I give the IAM user?
Admin.
Admin privilege.
Admin, administrator.
Right. And then you can use your account through that user that has all the privileges, right? But the root user, don't use it. Not recommended in production, right? Here we can use it, and we actually are using our root account, but we're just testing, we're exploring, we're experimenting with AWS. But if you have a business and you have sensitive data in your account, so delete or disable the keys for the root user and create admin access for users, IAM users. Okay, that's the best practice. And put the user in a group. Okay, that's the second part. Put the user in the group and give admin privileges to the group, not to the user, because that's not good practice. If you have 1,000 users, you're not gonna go one by one and give them admin privileges. So just give privileges to the group and then just dump all the users in the group, right? That's the way you do it. Introduction to the AWS Web Architecture Framework Design Principles, right? So as we go through the rest of these module sections, we will be prompted to review the architecture of a fictitious company against the AWS Web Architecture Framework Design Principles for each of the pillars. Okay, so we have here operational excellence, security, reliability, performance efficiency, and cost optimization. Guys, just save this in your hard drive because I'm going to ask you again at the end of the class. Okay, these 5 guys. So we have any company background, just a company. So any company background, the architecture, you will be reviewing this architecture. So any company background was founded in 2008 by John Doe. Okay? It sells high quality 3-dimensional 3D printed cityscapes of a neighborhood or neighborhoods that enable you to see individual buildings and trees. The cityscapes are printed in color with brickwork, roofs, gardens, and even cars in their correct coloration. The company is about to apply for private investment to fund their growth until their initial public offering, IPO. John and the board have asked you to perform an independent review of their technology platform to make sure that it will pass due diligence. John was interested in using cloud computing from the start. In 2008, he created an account with AWS and spun up his first Amazon Elastic Compute Cloud, Amazon EC2 instance. Over the years, the architecture of any company platform has evolved. John now has a team of 5 technologies who write and operate all the technology in the organization. John still writes core code for extracting structure from motion, but he has given the AWS account root user credentials to the rest of his team to manage. So what do you think about that? Okay, let's continue. Right? Now, any company corporation has 3 main departments. Fly and Snap, that's image acquisition and pre-processing and storage operations. Show and Shell, promoting, selling, and working with customers. And Make and Ship, manufacturing of products and delivery. So this guy gave access to all the people in his team to the root account. The high-level design for any company platform looks like the organizational structure of the company, right? So we have all this, how they work here, show and shell, and then they request imagery from this guy that have image acquisition, and then they also just send orders to this make and ship department, and then they can track orders as well here. They track orders, and then this guy can request imagery from this guy too. Okay, so this is a whole machinery of processing of objects, right? Now, we have here something that looks, scary, right? right? Bunch of stuff here, right? This is the flies and snap department, right? Like we saw here, right? The three main departments, that's one of them. So multiple devices, currently camera and video cameras, right, are mounted on lightweight aircraft that capture imagery of major cities, including famous locations on a scheduled basis. Each device generates imagery assets that are time-stamped with a clock that is synchronized with the aircraft's clock. The imagery assets are streamed to the onboard capture machine that has an external storage array. The capture machine is also connected to the aircraft's flight system and continuously captures navigation data, such as global positioning system GPS data, compass readings, and elevation. When it returns to base, the storage array is disconnected and taken into an ingest bay. And here, the storage array is connected to an ingest machine. The ingest machine creates a compressed archive of the storage array and uses file transfer protocol, FTP, to send it to an EC2 instance preprocessor machine. After the storage array has been processed, the archive is written to tape for backup. The storage array is then cleared and ready for the next flight. Tapes are held offsite by a third-party backup provider. The preprocessor machine periodically processes new data sets that have been uploaded to it. It extracts all the imagery assets and stores them in an Amazon Simple Storage Service Amazon S3 bucket. It notifies the imagery service about the files and provides it with the flight information. The imagery service uses the flight information to compute a 3D orientation and location for every moment of the flight, which it correlates to the imagery file timestamps. The information is stored in a relational database system, RDBMS, that is based in Amazon EC2 with links to the imagery assets in Amazon S3. Okay, that's what the fly and snap department does. Okay, now the show and shell. The show and shell, when customers visit any company website, they can see images and videos of the physical product. These images are in a variety of formats. For example, a large-scale walk-around map. The website uses elastic load balancing with Hypertext Transfer Protocol Secure, HTTPS, and an auto-scaling group of EC2 instances that run a content management system. Static website assets are stored in an S3 bucket. Customers can select a location on a map and see a video preview of the map of the cityscape. Customers can also choose the physical size of the map, choose the color scheme available in white, monochrome, or full color, and have the option to place light emitting diode LED holes in the map to build illuminated maps. The mapping service correlates to map location input from the website with the imagery service to confirm if imagery is available for that location. If the customers are happy with the preview, they can order their cityscape. Customers paid by credit card and credit card orders are processed by certified third-party payment card industry, PCI compliant provider. Any company does not process or store any credit card information. After the website receives payment information or confirmation, it instructs the order service to push the order to production. Orders, including customer details, are recorded in the show and sell database, which is on a relational database management system that is based in Amazon EC2. To initiate a video preview of full print of an order, The order service places a message on the production queue, which allows this render service to indicate when a preview video is available. The order service also reads from the order status queue and records status changes in the show and sell database. Customers can track their order through manufacturing and see when it has been dispatched, which is handled by a third party through the broker dispatch service. That's what show and sell does. Now, make and ship. Any company has proprietary technology that enables it to generate 3D models from a combination of photographs and videos, extracting structure from motion. The render service is a fleet of G2.2x large instances. That's EC2 instances, instance type. The render service takes orders from the production queue and generates the 3D models that are stored in an S3 bucket. The render service also uses the 3D models to create flyby videos so that customers can preview the orders on the any company website. These videos are stored in a separate S3 bucket. Once a year, the team deletes all previews. However, models are kept in case they are needed for future projects. That is what? Amazon S3 Glacier. Okay. After a customer places an order, a message is placed in the print queue with a link to the 3D model. At each stage of the make and ship process, order status updates are posted to the order status queue. This queue is consumed by any company website, which shows the order history. The make and ship team has 4 3D printers that print high resolution and detailed color control models. An on-premises print conductor machine takes orders from the print queue and sends them to the next available printer. The print conductor sends order updates to the order status queue. The print conductor sends a final update when the order has been completed, passed quality assurance, and is ready for dispatch. Okay, so we have a company that is using AWS, right? And is inside of VPC. Is using this, bucket for images, right? Is using this imagery database, which is a database, relational database management system, right? Is using this guy, this another bucket for a website, study website, right? Is using this EC2 instances. This is the icon for EC2 instances. Is using a production queue, which is an SQS queue. We're gonna know more about that maybe later. Or if you're taking the solution architect class, you're gonna know more about this, right? So as you can see, they have a machinery here. And I like something about this company. I like the fact that they don't deal with credit card payments. That's a good thing, right? So they let a third party just process the payments, and they just get that. They just get rid of that. They don't care about that, and it's even less problems, less issues for them. So let the third party work with that. One of the companies that some companies use is Stripe. I don't know if you know about this company, guys. Stripe. No?
Yes, I know about it.
Stripe is a platform. It's a payment platform on the internet where you can just place your order, right? Maybe here, and you can here is your Stripe payment. So many companies use this, right? This is an API, right? And you just write the code in your code. Of course, you have to create the code, but they give you the instructions of how to call this API, and just use it to process payments, which is pretty secure, right? They have a free version and they have a paid version. Okay? I once created a full stack application, and I used Stripe, just the um, the basic one. Okay? Of course, they make money, right? They have to make money for transactions, 2.9% plus 30 cents. Okay. So I like the fact that this company is using a third-party company for the payments, and also like the fact that they're using a third-party company to process the orders, which is pretty good, right? I like that. I like that. That takes a lot of overhead of them. Okay. Now think about just give it a thought. Give it a thought to the fact that they're using here the 5 pillars of the what architecture framework. Okay. So they're using operational excellence because the way that is structured is a very effective way to do it, right? They integrating a lot of services in AWS to, accomplish excellence in the operations, right? They're using services that have security, because I see here that they're using security groups, right? You come here, they use security groups, so they're making this infrastructure secure. And also, if you go to the VPC level, then you're going to see that they have knuckles as well. They don't mention it there because they don't talk about the security part, but this company also should have this, right? Because they're using a lot of security groups here to make this more secure, right? And as you can see, it's a monster inside this VPC, right? It's a machinery that is, it's. I can imagine this like the movie Titanic when they put the image inside the ship, how those engines were moving, something similar like that, moving like a machinery, just crashing down everything that is in front of it. Okay? I can imagine that. They also back up their information, right, and back up that to tapes, right? Amazon also has something called storage gateway, and it has um, a tape way to store the information in a tape manner. Okay. So we're not gonna talk about this. If we have time, we talk about this later. But as you can see, at the end of this activity, there's no right or wrong answers. It's just a discussion about what you think and how they implement just the 5 pillars of the well architecture framework. Okay, so if we have time at the end of the class, we can have some discussion about this. Okay? But I believe that by the end of the class, you're gonna have a better idea of the 5 pillars of the well architecture framework. So let's talk about the first one. Okay, so the first one is the operational excellence pillar, right? It's just deliver business value to your customers, right? So, guys, if you have a business and you don't offer business value to the customers, they're not gonna go with you, okay? Because unfortunately, they have a lot of choices, right? So, what makes you different? What makes you unique that I can go with you, right? Why would I go with you if I have all the choices, right? So Amazon values that very highly, and they think that customers are their priority. Okay. By the way, when you read the 14 principles of leadership of Amazon, the number one principle of leadership is customer obsession. So Amazon is obsessed with their customers. And of course, these guys apply to every single position in Amazon. not only for AWS. If you want to work for Amazon, you will have to master these guys, okay, and apply them. Okay. So when you read the leadership, the principles of leadership, the first one is customer obsession. Okay. And then you have ownership, invent and simplify, learn and be curious, think big, rise for action. Okay. So leaders start with the customer and work backwards. So whatever you do, you're thinking about your customers. Okay. They work vigorously to earn and keep customer trust. Although leaders pay attention to competitors, they obsess over customers. Okay. And one of the principles is hire and develop the best. So they don't want someone that has, a simple knowledge about something. They want the best. So working for Amazon is hard. They have a very tough and intense interview process. Okay, we're talking about 8 or 9 interviews. Okay, they interview you like 2 times, and then the third interview they take you to the place, and they interview you on site, and then you start rotating and being interviewed by different people, and they're gonna just eat you alive with questions. It's hard to work for Amazon, and that's why Amazon is so successful, because they hire the best, right? So the focus is run and monitor systems to deliver business value and to continually improve supporting processes and procedures. Okay, that's the core of AWS operational excellence pillar. Okay, it's a core just to deliver business value. Okay. What are the key topics? Managing and automating changes, responding to events, and defining standards to successfully manage daily operations. Okay? We have services that work with this. As you advance in AWS, you're going to know more about this, about all of these services that make this machinery, if I may call it like that, work so excellently. Okay, so one of the things that is in the design, and the design of the operational excellence, is perform operations as code. When we see this guy, we're talking about our friend CloudFormation. CloudFormation is the guy that allows you to automate things through code. That's why it's called infrastructure as a code. So whenever you hear infrastructure as a code, that is our dear friend CloudFormation. Okay. And by the way, CloudFormation uses either JSON or YAML. Okay, I prefer to use YAML because YAML is less complicated than
when you're managing infrastructure,
JSON. Okay?
Sure. Maybe you're using runbooks and scripts to create and manage everything. Version controlling and keeping track of changes can be challenging. Things get even harder when you need to replicate your entire production stack multiple times for development and testing purposes. But provisioning an infrastructure stack directly from a collection of scripts isn't simple. Wouldn't it be great if you could create and manage your infrastructure and application stack in a controlled and predictable way? Introducing AWS CloudFormation. CloudFormation provisions and manages stacks of AWS resources based on templates you create to model your infrastructure architecture. You can manage anything from a single Amazon EC2 instance to a complex multi-tier, multi-region application. CloudFormation can be used to define simple things like an Amazon VPC subnet, as well as provisioning services such as AWS OpsWorks or AWS Elastic Beanstalk. It's easy to get started with CloudFormation. You simply create a template, which is a JSON file that serves as a blueprint to define the configuration of all the AWS resources that make up your infrastructure and application stack. Or you can select a sample pre-built template that CloudFormation provides for commonly used architectures, such as a LAMP stack running on Amazon EC2 and Amazon RDS. Next, you just upload your template to CloudFormation. You can also select parameters such as the number of instances or instance type if necessary. Then CloudFormation will provision and configure your AWS resource stack. You can update your CloudFormation stack at any time by uploading a modified template through the AWS Management Console, command line, or SDK. You can also check your template into version control so you're able to keep track of all changes made to your infrastructure and application stack. With CloudFormation, you can version control your infrastructure architecture the same way you would with software code. Provisioning infrastructure is as simple as creating and uploading a template to CloudFormation. This makes replicating your infrastructure very simple. You can easily and quickly spin up a replica of your production stack for development and testing with a few clicks in the AWS Management Console. You can tear down and rebuild the replica stacks whenever you want. Replicating a production stack could have been time-consuming and error-prone if you did it manually. But with CloudFormation, you can create and manage AWS resource stacks quickly and reliably. And there's no additional charge for CloudFormation. You only pay for the AWS resources that CloudFormation creates and your application uses. To get started, visit our website and launch your first stack with AWS CloudFormation today.
Nice. So if we have time today, we're going to launch Stack with the AWS. We're going to create an EC2 instance with the security group. Okay. So you annotate your documentation. Okay. Everything that is done, just document it for people to understand what's going on. Make frequent small reversible changes, right? Reversible is because you can go back to the previous version, right? Refine operation procedures frequently, try to improve them every now and then. Anticipate failure. The CEO of AWS said once, everything fails. So plan for failure, okay? Always plan for failure. Just think that something may fail and things always fail. So plan for that. So when it happens, you know what to do, right? And how to respond to that. Learn from all operational events and failures. Whenever you have failures or, it's like life, you make mistakes and you learn from them. So it won't happen again, okay? That's what it says here, basically. So the question is, how do you determine what your priorities are, okay? So those are some of the questions that you may ask yourself and other people that are trying to implement this, right? Okay. So the foundational questions for operational excellence fall under 3 best practices: prepare, operate, and evolve, as you can see here. Right? So the operational teams, they must understand business and customer needs so that they can effectively and efficiently support business outcomes. Operational teams create and use procedures to respond to operational events and validate the effectiveness of procedures to support business needs. Operations teams collect metrics that are used to measure the achievement of desired business outcomes. And business context, business priorities, and customer needs change over time. So it's important to design operations that evolve in response to change and to incorporate lessons learned from their performance. Okay. Now, prepare. How do you determine what your priorities are? How do you design your workload so that you can understand its state? How do you reduce defects, ease remediation, and improve flow into production? How do you mitigate deployment risks? And how do you know that you're ready to support a workload? So those are questions that you have to do before you go ahead and just architect, right? To get ready to, to just face all this if that happens, right? So operate, how do you understand the health of your workload? Okay? When it's operating, what do I need to know to understand why this is happening and why this is not happening. Of course, when something bad doesn't happen, we need to understand why it's not happening so we can just make that secure. So how do you understand the health of your operations? Okay? And how do you manage workload and operation events? Now, how do you evolve operations? It's like I said before, things change. There are more technologies, more functionalities, more features are added. So you have to be evolvable. So your system has to be evolvable, your architecture, right? So we're still here with this fly snap, show and shell, making sheep. Okay. This is like the continuation of that, but now focus on operational excellence. Okay. If we have time, we can talk about this later. Now, the security pillar. Okay. This is very important. Security is super important for AWS. Okay. Without security, there's no system, there's no business, there's no success. Security is super important. Can you imagine if you build a house and you don't put any doors and you just leave a hole there, both in the windows and at the door, and just you sleep inside the house and just there's no doors or windows? I don't think that you're gonna last long there. Okay, when the malicious people know that you are there without any doors or any windows, so you may be in trouble real quick. Okay, so this is to protect and monitor the system, right? Today I was teaching a class on security in the morning, and I was talking about that there's nothing 100% secure. Nothing is 100% secure. If someone tells you that something is 100% secure, that person made the system itself non-secure. Okay, because nothing is 100% secure. That doesn't exist, right? Crackers, not hackers, crackers will always find a way to penetrate a system. Always find a way, either through key logging, or shoulder surfing, or dumpster diving, or social engineering, or phishing, or man in the middle. I don't know. So many ways that they can try to penetrate like a Trojan horse, just penetrate your system, right? So the focus of this guy is to protect the information, the systems, the assets, while delivering business value through risk assessments and mitigation strategies. So we have the security pillar here integrated with the operational excellence. So here we're trying to deliver business value, and that's the focus of operational excellence, right? And at the same time, we're trying to protect the value that we're delivering, okay? Through different services. You can have CloudWatch, you can have CloudTrail, you can have X-Ray, you can have SQS, you can have security groups, you can have NACLs, you can have lusty load balancers, you can have CloudFront, you can have Route 53. You can have so many services working there to make your architecture secure. Okay? So you have to follow the best practices, the best recommendations from AWS, and your system will be secure. Okay? The key topics here is identifying and managing who can do what. That is what, guys? That is what? That is what? That is permissions, right? Authorization to do something. Okay? Those are permissions. I am. I can give you permissions to have full access to S3, and that's all you have, nothing else. So you can only do whatever you want with S3, but you cannot do anything with EC2, and you cannot do anything with something else. Okay? Just S3. I make you an admin, then you can do whatever you want, but not always what you want. Because remember, the one that has unlimited access is the root account. Administrators, they have more access than anyone else, right? But they have limitations too. An administrator cannot see the billing section unless it's given billing permissions. But with that administrator access, the administrator cannot see the billing section of the account. And I think that I can show it to you. Let me log into my account real quick. But I'm gonna do it with my, right now, I'm gonna get the information from the user, from my admin, right? Let me get the code here. Okay, real quick. Okay. Also, MFA, that's important to secure your account. MFA, an extra layer of security, multi-factor authentication. So I'm gonna come here to IAM, right? IAM on the security, right? Right here. So I'm gonna see this user. I'm gonna copy this guy here, which is the URL for me as an administrator, right? I'm gonna log out and I'm gonna copy this guy, okay? Right? So now I do this authentication error. Okay, let me, authentication error. Did I change the password or did I delete that user? Oh. Okay. Oh my God. I don't even remember the password I used for this. Okay, guys, I'll do it later. But believe me, I'm telling you the truth. If you're an administrator, you cannot see the billing information of, unless you're given permission to do that. But by default, you can't. Only the root user can. Okay. Establishing controls to detect security events, protecting systems and services, and protecting confidentiality and integrity of data. Okay. So, like I said before, AWS doesn't care about your data. AWS will not even know what you have in your data. They don't care. They give you the resources, but remember, your responsibility is the security in the cloud, not off the cloud. So they will take care of the rest. You are the one that protect your data. You are the one that protect your services. You're the one that protect your users, okay, and customers, right? Then the designs you implement the strong identity foundation, that's IAM, okay? Enable traceability. Can someone tell me what is the service that works with traceability?
Confirmation.
You are at the
Cloud Trail.
Cloud Trail. Don't forget that. That's a basic question in the exam. Cloud Trail is the one that records every single API call and every single action in your account. There's a free version and a paid version, okay? The free version is enabled by default. The paid version, you have to pay for it. You have to enable it, okay? Don't forget that. It will trace everything that is done in the account. Apply security at all layers, you know, at the layer of the level of the instance, at the level of the subnet, which is the level of the VPC, you know, all those securities, okay? Automate security best practices, right? Protect data in transit and at rest, okay? You can enforce that, right? You can create the, I think I showed it to you guys a few classes ago as well. You can enable encryption, right? In an S3 bucket, server-side encryption, and then whatever lands in that bucket is going to be encrypted by default, okay? And you can enforce encryption in transit, okay? You can enforce that, okay? Keep people away from data. Of course, data is sensitive information, so keep people away from them, right? Just give access to the data to those who requires that, only to those who. And prepare for security events, you know, prepare to just incident response, right? To respond to events that have to do with security breaches and security issues, right? Security questions, you know, identity and access management, right? How do you manage credentials and authentication? Okay, so how do you manage credential authentication? Remember credentials. What is the best place to store for credentials? What is the best place?
Secret manager.
Secrets manager. Don't forget that. And the second best place?
Parameter store.
Parameter store. And what is the service that contains parameter store?
Wow.
What is the service that contains parameter store? Systems, 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 broken record, system, system manager, systems manager. Don't forget that. Okay, let me do it again. Okay. Okay, systems manager. Okay, systems manager, parameter store, right here, you see it? Parameter store, systems manager, don't forget that. How do you control human access, right? How do you control human access? Security is not only virtual security, it's also physical security. So how do you control that? Do you have badges or car keys? What do you have? You have, permissions, like fingerprint biometrics. I don't know. What do you have, right? What do you have to implement that, right? How do you control programmatic access? So how do you control the access through the CLI or SDKs? How do you control that? Okay, so that will be, questions for the security pillar. Detective control, how do you detect and investigate security events? Do you have an IDS, an intrusion detection system? Do you have an IPS, an intrusion prevention system? How do you work with it? How do you defend against emerging security threats? Do you have any security in place that will, respond to that? How do you respond to that? Threats, there'll always be threats. Guys, when I worked in the College Board in Virginia, very first day of work, the first day of work, guys, day number one, they gave me a Mac computer because all the developers, they use a Mac computer there. They think that Mac is more secure, so they use Mac computer. Everybody, MacBook Pros. Everybody has a MacBook Pro, okay? At least my department, okay? When I got home, I noticed something strange in my computer. My computer was being attacked since the moment I left the office until the next day. Because the College Board is the company that created the SAT exam. And it has data for millions and millions of users, right? It has data from the test takers, data from the users, because a user can be a test taker, but also someone that works for the College Board, right? They have data from the proctors of the exams, for the administrators, for everybody, right? For the person that cleans the floor, for the janitor. Any person is there in that data, right? But my computer was prepared by the security department to reject those attacks. So what it was doing was detecting it and rejecting it. So I just noticed something weird, that a lot of rejections and attack rejections were happening in my account. There will always be attacks, and you have to know how to respond to that. You have to, when you create an application as a developer, you and the security department, the experts, they have to be in line. They have to be on the same page, because you have to secure your applications from the get-go. They cannot be separated. It has to be together as a team. Security is super important. So how do you protect the infrastructure? How do you protect your networks? So what do you do? What are you using? How do you protect your compute resources? Okay, remember, one of the ways to protect your network is using an ACL, and one of the way to protect your compute resources In this case, EC2 is using a security group. That's one of the ways, right? That's the firewall of your resources. Data protection, how do you classify your data? Is it sensitive? Is it confidential? Is it public, right? How do you protect your data at rest? Are you encrypting your data at rest? Do you have server-side encryption? Okay. Are you creating versioning just in case someone deletes the data in an S3 bucket, right? How do you protect your data in transit? Are you using SSL certificates? Are you enforcing the encryption in transit, right? Incident response, how do you respond to an incident? So whenever these things happen, you have to be ready. Guys, there's no option here. There's no option here. There's not a choice. You have to be ready to respond to that. You cannot prepare when it happens because you may lose a whole lot of data. Okay? And it could, because you may lose your job because of that if you are the security expert of the company. So this is the same thing, but now applied to the pillar of security. Reliability pillar, right? So the focus of these guys is to prevent and quickly recover from failures to meet business and customer demand. Okay? So how fast can you recover? How fast can you up and running again? Okay? How fault tolerant are you? Right? When your system is down, what is your capability of stand up and continue running? Okay? So that's the focus of the reliability pillar. And this is very evident in Netflix. Guys, every time I want to think about AWS, I think about Netflix. Because Netflix was, like I said before, it was the first company to go all in the cloud, right? They just decided, they just analyzed all the options and just thought AWS is super secure and reliable. Let's go all in, right? And they just moved all the infrastructure, their resources to AWS. And when you see how they operate, very rarely do you see a Netflix down. Very rarely. They may be down, okay, but in a year, how many times is it down in a year? 1, 2, 3, 4 times, 10 times in 365 days of the year. But when they're down, unless there's a fire in a data center or a disaster, major disaster, an earthquake or a seaquake or something, or a tsunami or something. But when it's down, it's seconds. The downtime is very low, right? So when I think about AWS, I think about Netflix, and I see how reliable AWS is. And that's what AWS transmits to his customers, to the customers, that reliability. And then you, in turn, can offer that reliability to your customers, right? Because maybe you are a company working with services from AWS, you are an AWS customer, but at the same time, you have customers benefiting from your services, right? So it's just a chain of benefits, right? Reliable effects, right? When you work with AWS. So what is the key topics here? Just setting up, cross-project requirements, right? Recovery planning, and handling change. Every time there's a change, you have to be ready for it, okay? Every time that something evolves, you have to be ready for it, right? Your application has to be scalable. It has to be maintainable, right? It has to be recoverable, right? It has to be ready for change, okay? It has to be ready for change and for growth, because technologies evolve, and then the more you become more reliable, the more reliable you become, the more confidence and trust your customers are going to have in you, right? So what is the design principles of this guy, the reliability? The test recovery procedures, right? You could do some penetration testing, right? You can test your own services. AWS lets you do some penetration testing, but for some services you have to ask for permission because you are using their platform, right? You're using their infrastructure. It's AWS's, it's not yours, right? So you have to be careful when you do penetration testing. Okay. Automatically recover from failure, right? You have to be able to automatically recover. Do you guys think that there's a person behind the server in Netflix just waiting for the server to go down and manually fix the server? No. So you have to be able to automate that process too, right? Auto scaling is one of the guys that helps you automate your recovery, right? When a server is down, what happens? You create another one. Guys, did I show you how auto scaling works? Did I show you that? Yes or no?
I think that yes, when you terminate one instance and it recreate another one.
No, auto scaling is when it grows, right? Horizontally?
Correct.
Okay, no, we haven't seen it.
You haven't seen it?
No.
No.
Sure. Okay. Okay. So let me do it real quick here. I think I did it.
Yes, but when you have 4 instances and you have the auto scaling and you terminate 2, it's not supposed to increment 2 instances.
Yeah, create 2 more. I did that, right?
Yeah. You did it.
Okay. Yes. If your desired capacity,
Okay, I see it.
if your desired capacity is 2, it will always be 2. If one becomes unhealthy, it will create 1 for you. It will always meet the desired capacity that you guys establish when you create the auto scaling group. It will always meet that desired capacity, right? But you can do that based on values of the CPU. Okay, so if you say if the CPU is greater than 80%, so your server is bombarded with a lot of requests, and the CPU is greater than 80%, create 2 more EC2 instances, and then you can offload that, the burden of that particular server, and then the traffic can be in conjunction with the elastic load balancer. You can just distribute the traffic in the 3 instances. So that's auto scaling. Auto scaling will always meet whatever desired capacity you set up at the beginning of the configuration of that. All right. You scale horizontally to increase aggregate system. That's exactly what I'm talking about here. Okay. Remember, horizontally is scale out and in. That's horizontal. Don't forget that. It may be in your exam. Horizontal scaling is in and out, right? That means more servers or less servers, increasing the number of servers or reducing the number of servers. That's horizontal scaling. If it is vertical scaling, it means increment the power of your instance, right? If it is up, if it is down, is reduce the power of your instance. We're talking about more CPU when it increments the power, more CPU, more RAM. You increment the instance type. You go from, for example, from T2 micro to X5 that large. You increment the instance type. When you scale down, it's the opposite process. You just reduce the capacity of the instance. So vertical is more power or less power. Horizontal is greater number of instances or smaller number of instances. Don't forget that, okay? Scaling out, in, up, and down. Don't forget that. And you can manage change in automation, okay? So what are the questions for the reliability pillar? How do you manage service limits, okay? There are service limits for a new account. For example, you can only have 5 VPCs in a region. You can only have 20 instances per region, right? So if you want to create 21, you'll not be able to do that. That's a soft limit, okay? It's a soft limit. That's for new account. If you want to improve or increase the limit, you can place a request to AWS. And if you have shown a history of a solid and compliant and reliable service business, they can increase your limits. Okay. It's when you start selling for Amazon, for example, start selling for eBay, they're not gonna give you all the benefits at first. They don't even know you. No one knows you, right? And for example, when you sell for Amazon, you can only store, if you're doing FBA, fulfillment by Amazon, you can only have 200 products or 200 200 instances of that product. It's like 200 products of that product. I don't know if you understand what I'm saying. If you're selling, for example, a soccer ball, like a football, then you can have only 200 footballs, no more than that, of that color, of that type, right? If you have a blue football, then you can have 200 of that football. It's like 200 SKUs, 200 products per SKU. That's what they call it. But as you start selling and Amazon starts seeing that you are a reliable seller, and then people are just leaving good reviews, feedback about your product, then you can increase and you can have unlimited products in your account. Okay, the same thing with AWS. You start with limits, right, for new accounts, and then you can start, increasing as you go, and as you become more reliable as a business, right? How do you manage your network topology? Is it a mesh topology? Is it a star topology? What topology do you have, right? Change management. How does your system adapt to changes in demand, right? So yours, one of the characteristics of a good application is adaptability. So it has to be adaptive, right? Be able to adapt to changes, right? If your application is not adaptable, then you are doomed to disappear, because technology is increased, like I said before, improve, change. So your application has to be able to adapt to changes, right? How do you monitor your resources? In AWS, we have CloudWatch, right? That's our best friend. That's our best friend for monitoring, right? And how do you implement changes, right? We have another service that's called AWS Config. That is the one that is used for notify you of every single configuration change of your application. Okay, that's another one that you may have in your exam, right? So this one here, for example, AWS config. Right, so we have Chetu. What's that, Chetu? I don't want that. AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources. Config continuously monitors and records your AWS resource configurations and allows you to automate the evaluation of recorded configurations against desired configurations. So it will tell you what service is compliant, what is not compliant, what port is open, what port is not open. You just have to create a rule. Okay, so if you come here, just AWS config, right? Right here, or config, right? So you can create something called rules here, right? You can call a rule and say just whatever you want to say here. And rule, right? And you can add an aggregator here and just establish a rule here to, for example, know what ports are open. For example, here, you can have here, let's say ports, restricted common ports, check whether security ports that are in use disallow or restricted incoming TCP traffic to the specified ports. And NCM, account certificate manager, Amazon certificate manager, certified expiration check. You're gonna check if they are expired, and it's gonna show you all the ones that are expired. I can select this one, right? And then I can check the port that is open or not, right? Blocked TCP port numbers, okay? So I can have that and check just whatever I want to check, right? Failure management, how do you back up your data? You do it daily? Do you do a snapshot of your EC2 instance? Do you save it in this S3 bucket? How often do you do that, right? Are you able to restore your services if something happens, right? How does your system withstand component failure? How do you test resiliency or resilience? How do you plan for disaster recovery? Okay, so those are questions that you guys can ask yourselves for that. Again, the same thing, but now apply to reliability. Right? So now we have the performance efficiency pillar. What is the focus of this? Use IT and computer resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So here we have auto scaling again, okay? And it says here, use resources sparingly. What is the meaning of that? Do you guys have an idea what is the meaning of that? What do they, mean by that? Okay, it means that you guys have to select the right resources types. Be careful when you do it, right? Use it in a restricted or infrequent manner, in small quantities. Don't use a lot, right? Just use the ones that you need, right? And instead of using a big instance, use, for example, 10 instances that accomplish the same. Okay, that's much better from the availability standpoint, because if you have one big massive powerful instance and you lose it, you lost everything. Okay, so it's better to have 5 instances that accomplish the same as one big one. Okay, select the right resource types and sizes based on workload requirements. Just you have to study your business. You see the patterns of traffic throughout the year, and then just select the right size and the right resource. Reserve if you can, right, to save money. Monitor performance all the time. Use CloudWatch. Your CloudWatch is by default, right? And the basic one, which is every 5 minutes, we give you. It will give you metrics every 5 minutes, right? If you just go for the enhanced one, right? The advanced one, the enhanced monitoring, you can get metrics for 1 minute, every 1 minute. They're gonna pay for that. That is not free, right? By default, the basic is the one by default, and it's the one that you don't pay for. Okay. You can even have metrics every second, but it's gonna cost you more. That's a high resolution metric. Okay. Guys, CPU is a metric, right? CPU is a metric of CloudWatch. RAM, memory, is not a metric. Be careful in the exam if they try to get you with that, right? RAM or memory is not a metric, okay? CPU is a metric. Memory is not a metric. Memory is a custom metric. You will have to create it. It is not by default, okay? Very important. Making informed decisions to maintain efficiency as business needs evolve. That's the key topics of this. Guys, do you have any questions? Let me stop for a minute to ask you if you have questions. No?
No.
Okay, guys, if you don't have any question, I think it's time for a break. It's 6:46. Let's break for 10 minutes, and let's meet you back here at 6. let's meet back here at 6:56. Okay. So guys, we continue. So we were seeing here that talking about this guy, the performance efficiency, right? And then what do we do with democratize advanced technologies? So we consume technologies as a service. For example, technologies such as NoSQL databases, media transcoding, machine learning require expertise that is not evenly dispersed across the technical community. So those are more sophisticated, advanced technologies, right? In the cloud, for example, these technologies become services that teams can consume. Consuming technologies enables teams to focus on product development instead of resource provisioning and management. So we can go global in minutes. It's easy to start with AWS just with a few clicks, right? Just to create an EC2 instance is a few clicks. Just creating a template in AWS, it's very simple too, right? A template in CloudFormation, just uploading the code in last to be installed and deploying it. It's very simple. Also, using for example, Amplify, right? So we have another service here called Amplify, right? Amplify, right? And this service is very good. I don't have this information now, but this is just a small React application that I was testing. I was testing Amplify, right? And you can connect this to a code commit repository. Okay, this is a repository that I have in code commit. Let us wait for that to load. Okay, so the repository doesn't exist. I don't know why still deploying that. Very weird. And I'm gonna delete this guy because I don't need it. Okay, so I'm gonna app. I just call it app, and don't delete this guy. Please check your inputs. Oh, type delete. Okay, not the name delete. And then I delete it. So it's been deleted now. It's deleted in the deleted process, right? But this guy is very, and it took a short time because it's a very small application. Okay, it just takes minutes with that, right? So now we have the performance of use serverless architecture. Very highly recommended to use serverless. Use Lambda instead of EC2 instances, for example. Experiment more often. Just try to explore all the services with AWS. Watch videos. Become more acquainted, more familiar with AWS resources, right? And have mechanical sympathy, right? By mechanical sympathy is just the use of the technologies approach that aligns best to what you're trying to achieve. For example, consider your data access patterns when you select approaches for databases or storage. Okay, just evaluate your customers how they access your data, and based on that, you can choose your storage or database choices. Cost optimization pillar, right? This is about money. Okay, so try to avoid the unnecessary expenses. Okay, run the systems to deliver business value at the lowest price point. Okay, guys, when you are in an interview and they ask you, how would you architect just a business from the AWS standpoint? How would you architect? Don't leave cost aside. Don't leave it out. Cost has to be there. That could be one of the questions in an interview. You may just finish presenting a magisterial speech. Oh, wow, this guy knows a lot about AWS. How about cost? And you forgot a very important key element in your speech: cost. Okay, so the cost of this pillar is just deliver business values at the lowest price possible. And key points is understanding and controlling where money is being spent. Where is the money being spent and when? Selecting the most appropriate and right number of resource types, right? Analyzing spending over time. That's, you can use other cost explorer. Yeah, you can use the pricing calculator, right? Budgets, um, usage and reports, things like that you can use. Scaling to meet business needs without overspending. Auto scaling is the expert in that, right? But you have to make sure that you create a scaling policy, right? That is well thought out, and because auto scaling will do whatever you tell it to do, right? Right. Auto scaling is just a service; it's not a person. So you're the one that have to think, how many EC2 instances I need if this CPU value is greater than 80. So you have to adopt a consumption model, right? You pay only for the computer and resources that you require, right? Increase or decrease the usage depending on business requirements, not by using elaborate forecasting. You have to measure overall efficiency. You measure the business output of the workload and the cost that are associated with delivering it. Okay. Stop spending money on data centers operations. Okay, that's one of the 6 benefits of the cloud. Okay, so AWS would do the heavy lifting, racking, stacking, and powering servers, which means that you can focus on something else, on your customers and business projects instead of IT infrastructure. Right? Analyze and attribute expenditure. Right. The cloud makes it easier to accurately identify any system usage and costs, and attribute IT costs to individuals, workload owners. So having this capacity or capability helps you measure return on investment, ROI, and gives your workloads owners the opportunity to optimize their resources and reduce cost. Right. Use managed and application level services to reduce cost, right? So this will reduce, for sure, the operational burden of maintaining servers for tasks such as sending emails or managing databases. Now, because managed services operate at cloud scale, right? Cloud service providers can offer a lower cost per transaction of service, right? Cost optimization questions, expenditure awareness. How do you govern usage? How do you monitor usage and cost? How do you decommission resources? Once they're not needed anymore, how do you commission them? Right. Cost-effective resources, how do you evaluate cost when you select services? What do you do to select the best service? Right. What do you meet cost targets? How do you meet cost targets when you select resource types and size? How do you use pricing models to reduce cost? How do you plan for data transfer changes? Matching supply and demand. How do you match supplies and resources with demand? And optimize it over time. How do you evaluate new services? As your technology evolves, then you have to optimize that over time. Same thing. The AWS Well Architected tool, it helps you review the state of your workloads and compare them to the latest AWS architectural best practices. And it gives you access to knowledge and best practices used by AWS architects whenever you need them. It delivers an action plan with step-by-step guidance on how to build better workloads for the cloud. And it provides a consistent process for you to review and measure your cloud architecture. So in other words, the AWS well-architected tool provides a consistent process, right, that results, it brings the results that the tool provides to identify to next steps, the next steps for improvements. And also it drives architectural decisions, bring architecture considerations into your corporate governance process. So all of this is something that you guys can implement, all these questions that we have talked about in the well-architected framework with the 5 pillars are things that you can just gather and have a good set of questions to start the process with the company. Remember, when you start building something, you have to get the requirements from the client. That you need to know what the client wants and how the client is planning to do something, right? And based on that, once you have finished your interview with the client, then you start planning and architecting. Right? Now, key takeaways here: the AWS Well Architected Framework provides a consistent approach to evaluate cloud architectures and guidance to help implement designs. This is just repeating what we saw already. Okay. The AWS Well Architected Framework documents is a set of foundational questions that enable you to understand if a specific architecture aligns well with cloud best practices. And the AWS Well Architected Framework is organized into 5 pillars, and you guys mentioned them. Can you guys mention them?
Operational excellence.
Good.
Security, reliability,
Which one? Which one?
reliability,
Reliability. Okay. What else?
Cost
optimization.
security,
Cost optimization, security, and
Resilient.
performance efficiency.
performance efficiency. Okay. Those are the guys. Operational excellence, reliability, security, performance efficiency, and cost optimization. Don't forget that, guys. That's very important. And every single pillar includes a set of design principles and best practices. Right. Now about reliability and availability. So the CEO of Amazon, Werner Vogels, said this: everything fails all the time. Everything fails all the time. So one of the best practices that is identified in the AWS well-architected framework is to plan for failure or just the application or workload downtime. You have to work for that. Okay, you have to plan for that. One way to do that is to architect your applications and workloads to withstand failure. There are 2 important factors that cloud architects consider when designing architectures to withstand failure, and they are reliability and availability. Okay, that's what you plan when you think about failure. Okay, so what is reliability? It's the measure of your system's ability to provide functionality when desired by the user. So it means that the resources are there when you need them. That's what it basically means. Okay. Now, one of the ways to measure that, right, it's to use a statistical measurement, such as the mean time, like here, mean time between failures, NTBF. So the mean time between failures is the total time in service over the number of failures. Okay, so it's the mean time between failures. How much does it take between failures? That's the total time in service numbers of failures. Right? So the system includes all system components: hardware, firmware, and software. So we're trying to make everything reliable. Not only the software, also the hardware, the firmware, and the software. Of course, when we are in the cloud, we're not working with hardware, right? As to the resources of AWS, we're working with computers, right? But When I'm working with servers, when I'm working with data centers, when I'm working with cabling, things like that, that's AWS's responsibility. Right? Also, the probability that your entire system will function as intended for a specific period. So also that measures your reliability. Okay? And the meantime. So we have a car here. A car has brakes, and it has a cooling system, and it have ignition. So these are the components of the car, right? So that, when you have the car, that includes everything if you want to make it reliable. Just give me 1 second, guys. So, sorry, guys. So that will also, if you want to evaluate the reliability of the car, you can have, you can just include those components here. Okay. Okay. Because basically they are part of the car. Right? The car is nothing without these guys. Okay. Same with the system. Any system that has hardware, firmware, and software. So everything is included and makes the whole unit reliable or not. So here we have understanding reliability metrics. So say that you have an application that you bring online Monday at noon, right? So the application is said to be available. It functions normally until it fails Friday at noon. Therefore, the time to failure, or the length of the time the application is available, is 96 hours. As an example, you spend from Friday at noon until Monday at noon diagnosing why the application failed and repairing it, at which point you bring the application back online. Therefore, the time to repair is 72 hours. Right? Then it happens again. The application fails on Friday at noon. It seems that it's doomed to fail at Friday at noon. You spend from Friday at noon until Monday at noon repairing it, and you bring it online on Monday at noon. Say this failure, repair, restore cycle happens every week. So you can now calculate the average of these numbers. In this example here, your mean time to failure is 96 hours, right? And your mean time to repair is 72 hours, which is the MTTR, right? So the mean time to failure is MTTF. Which one? And this is the mean time to repair, which is MTTR. Your mean time between failures is MTBF. It's 168 hours of 1 week, which is the sum of this and this, and then you get this. So 168 hours is your mean time between failures. Okay. So that's how you measure that. This is mostly for system administrators, right? But they can, have all this machinery in place so they can understand the reliability of the system, right? Availability, number operation time divided by total time. Right. So as we just learned, failure system components impacts availability of the system. If the system is not reliable, that will affect the availability of the system. Right? So formally, availability is the percentage of the time that the system is operating normally or correctly performing the operations expected of it. Right? Availability is reduced anytime the application isn't operating normally, right? Including both scheduled and unscheduled interruptions. So also availability is also defined as the percentage of uptime, that is length of time that a system is online between failures, including over a period of time, commonly 1 year. Okay, so it's the percentage of uptime, which, for example, 99.9% over time, for example, 1 year. Okay. A second shorthand when referring to availability is number of nines. For example, 5 nines means 99.999% availability. Okay. Remember the durability of S3 bucket, which is 11 nines, right? And the availability is 4 nines, 99.99. Okay. So that's how it works. Now, this is the core of AWS, one of the core concepts of AWS, high availability. And if you guys are going for this solutions architect exam, this is the center of the exam. This is the heart of the exam, high availability. And you always, as an architect, you have to plan for this. You have to make your service highly available. Okay. Your services. So the system can withstand some measure of degradation while still remaining available. That's what I said about Netflix before. Okay, so there's some degradation of probably 5 seconds, right? But still remains available because it's gonna be super fast. The downtime is minimized, right? And there's no, in the case of auto scaling, there's no human intervention at all, right? So when you automate, you're trying to leave the human component out. We're trying to automate things, right? Now, a highly available system can be viewed as a set of system-wide shared resources that cooperate to guarantee essential services. High availability combines software with open standard hardware to minimize downtime by quickly restoring essential services when a system component or application fails. Services are restored rapidly, often in less than 1 minute. Okay, so that's the goal, to be able to restore your services in less than 1 minute. It may take less than half a minute. It all depends on how fast it is. Okay. Availability tiers. So we have 99%. It's 3 days and 15 hours. That's the maximum interruption. Okay. That's for batch processing, data extraction, transfer, and load jobs. 99.9, 3 nines, right? 2 nines, 3 nines now. 8 hours and 45 minutes. Internal tools like knowledge management, project tracking. 99.95%, that's 4 hours and 22 minutes. That is online commerce, point of sale. 99.99%, that's 52 minutes, video delivery, broadcast systems. And 99.999, 5 nines% is 5 minutes, ATM transactions, telecommunication systems. And this is per year, guys. This is per year. So the availability requirements vary. The length of disruption that is acceptable depends on the type of application. This is just a table, right, of common application availability design goals and the maximum length of disruption that can occur within a year while still meeting the goal. So this table contains examples of the types of applications that are common at each availability tier. Okay? It's just a table. The values can vary depending on the application, the complexity of the application, and the size of the application. Factors that influence availability: fault tolerance, scalability, and recoverability. Okay. Now, fault tolerance refers to what? Sorry about that. It refers to the built-in redundancy of an application's components and the ability of the application to remain operational even if some of its components fail, right? And thus, this is the concept similar to the concept of microservices and containers, right? So one is self-contained, these components are self-contained, right? When one of them breaks, then the other ones will still continue to operate, okay? So fault tolerance it relies on specialized hardware to detect failure in a system component, such as a processor, memory board, power supply, input-output subsystem, or storage subsystem. And instantaneously switch to a redundant hardware component. The failure-tolerant model does not address software failures, which are the most common reason for downtime. Now, scalability, right, is the ability of an application to accommodate increases in capacity needs without changing design. It does not guarantee availability, but it contributes to your application's availability, right? Recoverability is the ability to restore services quickly and without lost data if a disaster makes your components unavailable or it destroys the data, right? So it's the process, policies, and procedures are related to restoring service even after a catastrophic event, right? So fault tolerance is the ability to remain operational even when some of the components are down, right? Scalability is the capacity of accommodate increases in capacity without changing the design, right? And recoverability is that capability of restoring service after a catastrophic disaster. Okay, those are the factors that influence availability. So what is reliability? It's the measure of your system's ability to provide functionality when desired by the user, and it can be measured in terms of MTBF, median time between failures, right? Availability is the percentage of time that a system is operating normally or correctly performing the operations expected of it, or normal operation time over total time. 3 factors that influence the availability of your application: fault tolerance, recoverability, and scalability. You can design your workloads and applications to be highly available, but there's a cost trade-off to consider. Okay. Trusted advisor. This is a tough guy. This is the cloud expert. Okay. There's two flavors of trusted advisor. There's the basic one, and there's the full trusted advisor. The full trusted advisor is the one that has all the periquitos, all the good things about trusted advisor, right? It's an online tool that provides real-time guidance to help you provision your resources following AWS best practices. It looks at your entire AWS environment and gives you your real-time recommendations in 5 categories. Recommendations, guys, recommendations. Don't forget that. Okay. Cost optimization, right? If you see this guy is a warning, okay? So something is not right. This guy is telling you that everything is okay, right? And this guy is telling you that something is wrong. That's an alert there. Something has to be fixed, right? So these are the five categories of trusted advisor. Cost optimization, okay? Very similar to the cost optimization pillar of the well-architected framework, okay? Performance, very similar to the performance efficiency of the well-architected framework. Security, very similar to the security pillar of the AWS well-architected framework. Fault tolerance is one of the factors that affect availability, and service limits. You will know your limits, right? You have limits, especially when it's a new account. Okay. So as to the limits, AWS Trusted Advisor will check for services usage that is more than 80% of your service limit. So the values are based on the snapshot. So your current usage might differ. Limit and usage data can take up to 24 hours to reflect any changes. So let's just interpret this here. Okay. So we have here a trusted advisor, and maybe you have a friend who used AWS Trusted Advisor for the first time. She's trying to interpret its recommendations to improve her cloud environment and needs your help. This is her dashboard, and while everything looks okay in the cost optimization service limit categories, you notice that there are a few recommendations that you should review to help her improve her security, right? And also performance and fault tolerance, right? So you can help your friend interpret this, right? So by this image that we see here, we can see from this image, we can see that something is wrong with these guys. Okay, so there should be some changes in the performance. It's not performing well, right? It's not secure enough, and it's not fault tolerant enough. So as to cost optimization, everything is fine. Service limit, everything is fine, but we have a problem here. So you can help your friend interpret this. Okay. And of course, when you are in AWS, you can come to Trusted Advisor, and then you can see more of this guy here. Okay. So in my case, it gives me recommendations here. It says check your security group for rules that allow unrestricted access to specific ports. Yeah, you guys know that I have created some resource and some security groups, and then I have used this guy. If I go to my EC2 instances and I check the security groups, we can see that there are some security groups that I created that have this guy here. Okay, so it's telling me that this is not secure at all. Okay, in a real world, you don't do this for SSH. You don't do that. You don't do that for RDP. Okay, and you just restrict the access to specific computer or specific computers or a specific range of ports of IP addresses. But you don't do 00 or 0.0.0/0. You don't do that. That's not good practice. But for the sake of studying these guys, I do that. Okay. So the backup permissions are fine. IAM use is fine. All these guys are fine. Just usually it gives you the warnings and concerns at first, the first in the list, okay, for you to see them visible. So everything is fine in my account except these guys that I've used here. If I fix these guys, if I just remove those rules there, everything will be okay with the security of my account. Okay. There's nothing about performance because basically this is just like a test account. And it's not supposed to perform anything. I'm not spending anything. If you take a look at my credits on my billing section, right? I'm using a lot of credits that I have. I haven't paid anything. I have credits that will expire soon. I have $732 that I need to spend, and they will expire. This expires on the 30th of November, and this one on the 31st of October. This one too. I still have like $100 that I haven't used here. Okay. And I have more here as well. Recommendation number 1. Okay. MFA on root account. Check the root account and warns if a multi-factor authentication is not enabled, right? For increased security, we recommend that you protect your account by using MFA, which requires a user to enter a unique authentication code from their MFA hardware or virtual device when interacting with the AWS console and associated websites. Alert criteria: MFA is not enabled on the root account. If I come to IAM also gives me recommendations here. The dashboard. Okay. Dashboard. Users, groups, management, dashboard. All right. So it says the root user has, you see a warning here, has keys enabled. We recommend that you delete the keys for this root user and instead use access keys attached to an IAM user to improve security. Okay. And they give you a bunch of best practices here. Grant least privilege access. It means I start from 0 and I increase the privileges as we go, as the job requires. Rotate the credentials regularly. Enable MFA, enable identity federation. Okay, use single sign-on. You can configure that. Enable IAM access analyzer. Rotate credentials, and start giving me a bunch of things that I should do in my account, right? And what is new in AWS. Of course, this is for a class, guys. I'm not gonna do this right now, but I should consider that if I'm taking an exam. Okay, that's very important. I like it here. MFA is not enabled on the root account. Just do it. Log into your account and activate an MFA device. Okay. So I think that if I put here MFA, it should give me IAM. And I am already. So the settings. Okay, delete the access keys. Policies. They keep changing this. Okay. Guys, my recommendation is if you are getting into AWS, you have to stay up to speed with AWS changes because they continuously change the UI. Before, as soon as you arrived here, you saw all the characteristics and you saw all the things that are in the AWS in your account, right? Okay. IAM password policy description checks the password policy for your account and warn when a password policy is not enabled, or if your password content requirements have not been enabled. Password content requires to increase the overall security of your AWS account environment by enforcing the creation of strong user passwords. When you create or change a password policy, the change is enforced immediately for new users, but does not require existing users to change their passwords. Alert criteria: a password policy is enabled, but at least one content requirement is not enabled. Recommended action: if some content requirements are not enabled, consider enabling them enabling them. If no password policy is enabled, create and configure one. See setting an account password policy for IAM users. Security groups, right? Check the security groups rules that allow unrestricted access, right? That increases the opportunity for malicious activity, hacking, denial of service attacks, loss of data. A security rule has a source IP address with a 0 suffix ports other than 2580 or 443. That's what happens to me, right? You see the IP guy here, the IP range. Then recommended is restrict access to those IP addresses that require it. To restrict access to a specific IP address, set the prefix is 32. That means that only one account or one IP address can access this. 32, this prefix means only one. Okay. Be sure to delete overly permissive rules after creating rules that are more restrictive. Right. Guys, don't do this, right? If you are in a real application, don't use this. That's not good, right? Just for testing, right? Snapshots, check the age of the snapshot for your Amazon. It has to be blog store volumes available or in use. Even though Amazon EVS volumes are replicated, failures can occur. So snapshots are persisted to Amazon Superstore service Amazon S3 for durable storage and point-to-point recovery. Durability, very important. 11 nines, don't forget that. Now, alert criteria, yellow, the most recent volume of snapshots between 7 and 30 days old. Red, the most recent volume snapshot is more than 30 days old. And red, the volume does not have a snapshot. Create a snapshot, highly recommended to be able to restore your EBS, okay? Recommended action, create weekly or monthly snapshots of your volumes. If you can do it every day, do it every day, okay? It all depends on your needs and how important your information is, right? S3 bucket logging, right? Description, check the logging configuration of the Amazon Simple Storage Service, Amazon S3 bucket. When server access logging is enabled, detailed access logs are delivered hourly to a bucket that you choose. Okay, so we can just enable S3 bucket here. So we can enable for example, this one. We can enable logging here, right here. And then you can use CloudTrail here. But this is not the one that I want, is this service access logging. Enable logging. And then you can choose a bucket, another bucket where to put the logging. So I can come here and S3 and create a bucket and say, bucket for logging Dunieski. Maybe if I don't put Dunieski, that doesn't exist. It exists? Okay, that's good. Oh, I knew. It's a very common name, but that one doesn't exist. Okay, so I'm gonna log everything, every access to this bucket, right? I want to log it. I want to save the logs in another bucket. So I'm gonna enable this, and then I'm gonna choose this, and I put them in the bucket for logging Dunieski, right? And this is optional, okay? Just in case I want to put them inside a folder that is inside the bucket. So I know now that whenever someone just uploads something here, let's see if it, let me see if it records that and logs it. So I'm gonna upload this. This is the guy, right? Okay, good. So I'm gonna just upload a file here and let's see what happens. Okay, just a cover letter. Okay, and then upload it. So I'm gonna see if that is logged in the other guy. Okay, so maybe it takes a while. Let us wait. Sometimes it takes a while. It's usually access, but let us see later. So logging here, criteria, yellow, the bucket has now server-side logging enabled. The target bucket permissions do not include the owner account. Trusted advisor can now check it, right? And then recommended action, enable bucket logging for most buckets. If the target bucket permissions do not include the owner account and you want trusted advisor to check the logging status, add the owner account as the grantee, okay, as the one that is granted permission, okay? Okay, so Trusted Advisor is an online tool that provides real-time guidance to help you provision your resources by following AWS best practices. AWS Trusted Advisor looks at your entire AWS environment and gives you real-time recommendations in 5 categories. You can use AWS Trusted Advisor to help you optimize your AWS environment as soon as you start implementing your architecture designs. Remember, recommendations, real-time recommendations, AWS Trusted Advisor. Don't forget that, okay? It's an online tool. It's a cloud expert that's gonna give you real-time recommendations of the things that you have to work on, like cost optimization, performance, security, fault tolerance, and service limits. Okay? Tough guy, nice guy. Okay. So today in this module, we learned, right, how to describe the AWS Well Architected Framework, including the 5 pillars, which are, tell me guys.
Operational excellence, security,
Right.
Yeah, reliability.
Reliability. Well,
efficiency.
Sorry?
Performance efficiency.
Performance efficiency. Okay. And operational excellence. Okay. Identify the design principles of AWS Well Architected Framework. Explain the importance of reliability and high availability. Identify how AWS Advisor help customers, and interpret AWS Trusted Advisor recommendations. Okay. Don't forget to do the knowledge check before Friday. Okay, that's very important. It will test your knowledge on this class, right? On this lesson. Sample question. A sysops engineer working at a company wants to protect their data in transit or at rest. What services could they use to protect their data?
All of the above.
A. V.
Perfect.
All of the above.
Perfect. Remember that you can encrypt an Elastic Block Store, right? Remember? Elastic Load Balancer has certificates. You can mount a certificate on Elastic Load Balancer, right? So a certificate, guarantees that the data is encrypted in transit, right? And Amazon SQL Storage Service, it has server-side encryption that everything that lands in that particular bucket will be logged there. Okay. So guys, it's not working because this is mostly for access, just in case you have a website or something and someone tries to access the website, then it will log when it was accessed. Okay, that's an access log. Okay. If you take a look at this, this is default encryption. This is server-side encryption, right? So when you try to access this bucket, either through the API or SDKs or whatever, even CloudFront or something, it will log that access into the other one, the bucket for logging, the Niesky bucket. Okay. So now these are the some of the links that you guys can have for the white papers and the labs. The labs are the ones that guys, I just opened all the labs for you guys to work with them whenever you want. Remember that you only have a few days to work in the labs and get, sharpen your abilities before you get to the exam, right? And right now, what we're gonna do is first, I'm gonna ask you if you have a question. Yes or no? Question? No questions? All right, guys. I'm gonna do the same thing as I did with the vouchers for the exam. Remember, I'm gonna give you the vouchers for the. Let me see here. For the practice exams, okay? I'm gonna do that, right? So I'm gonna choose exactly the same way that I did it, right? And we're gonna go to this website, okay? So we're gonna go exactly to the same. Let me share my screen real quick, okay? And then we're gonna take the practice exam, okay? As soon as you have that, right? As soon as you have access to that, just the voucher that I'm gonna share with you guys. As soon as you have it, you start taking the exam, okay? So we're gonna come here with this certification, the same thing. What is this? This is not the account. This is the account. All right, so we're gonna just go to my account and just we're going to schedule an exam, right? And then that's gonna be the practice exam. You see here, practice exam, and we're gonna look for the cloud practitioner right here. You see how here? So we come here and schedule with PSI. Okay. So you can go right there. I mean, right now, and just be ready for when I give you the voucher. Okay. You pay for the exam. You select the language here, English, right? You select the country, United States of America. You continue, request was successful. And then you introduce the code here that I'm gonna give you, and then you don't have to pay for this $20. The exam says here 50 seconds, but believe me, guys, you're gonna finish it earlier. It only has 20 questions. Okay, so get to this place and wait for me to give you the voucher. Okay, and start taking the exam as soon as you have it. Okay. All right, just be in the lookout for a message from me. Okay.
In Slack, right?
Sorry?
To be on a Slack.
On Slack, yes. So the metrics, I'm just sending you your code.
And we're gonna schedule with person view or with
PSI.
PSI?
Okay, the metrics, I gave you the code.
I didn't see a code.
So Anusha, I'm gonna give you the code. Check Slack. Check your personal
Oh, you
message.
saying Slack? Oh, I thought you were talking about in the chat.
Slack. Anusha, you have your code.
Can you show the
Thank
the URL for the test site?
AWS.training. Same as this exam.
Oh, because I'm getting a site can't be reached.
Okay, AWS.training is the same site that we use for scheduling your exam. So I just gave you the code, Taveen.
Thank you. Got it.
Delia, I'm gonna give you yours now. Delia. Dania, I'm gonna give you yours. Please confirm when you get it. Just give me a thumbs up and on Slack. Dania, I'll give you yours. Now this is for Dieva. I'm gonna give you yours now. Give you yours yet, Dieva?
Sorry.
I gave you your code for the practice exam.
Okay, thank you. Yeah, I know. I have my exam.
No, it's a practice exam that we're gonna take now
Okay.
from AWS.
Okay.
Edward Diaz, give you the code now. Now we have Fernando Mendoza. I'm gonna give you the code now. Please confirm when you get it. Just give me a thumbs up on Slack. Give it to you, Fernando Mendoza. Now I'm gonna give it to Hilda. Hilda, I'm giving it to you now. Now I'm gonna give it to Harold.
Got it.
Harold.
Can you go to the PSI exams online website and do the same, or it has to be through AWS?
Okay, so we go back here. AWS training.
I can't see your screen.
One moment, let me share my screen. Okay, AWS training, right? You come here, it says certification, right? You go to your account, right? And then